Hello and welcome to this short video where I'll try to explain Dell CSM App Mobility in 5 minutes. My name is Erik Sandboer and I'm part of the engineering technology group within Dell Technologies. So having CSI is cool and it allows us to have persistent storage into Kubernetes from all of our major platforms. The problem is it's limited to Kubernetes, which means you cannot do anything that Kubernetes obviously doesn't understand. This is where Dell Container Storage Modules, or CSM, come in. We extend where Kubernetes stops. So looking at the different modules that we have, you can see there's quite a lot of them at the moment. But today we'll be focusing on this particular one, App Mobility. It's still in tech preview, but it's a pretty cool module. It allows you to move a stateful Kubernetes application, so with persistent storage, between different Kubernetes platforms. So that can be from ground to ground, from one data center to the other. It can be from edge to your data center, or even into the cloud. Additionally, it can use group snapshots to make crash consistent copies of multiple persistent volumes that as a total build your application. Like I said, it's independent of the Kubernetes platform or backing storage technology, which makes it pretty cool. Lastly, it's fully open source, and of course it's built and supported by Dell. So how does it work? So let's say that we have a source Kubernetes cluster that's running, in this case, my little application with a CSI persistent volume attached on a source storage array. Now, I want to move this to the other side, to the target cluster and a target array. So please bear in mind that the Kubernetes platforms can be any supported platform, including OpenShift, Rancher, Vanilla Kubernetes, you name it. The same holds true for the storage array technology, right? It can be Unity, it can be PowerMax, PowerStore, or even non-Dell arrays. So in this case, we will be moving my little application from the source Kubernetes cluster from the orange storage array to the blue one. So in order to do that, we first install App Mobility on both source and destination clusters. We need an S3 bucket for like a temporary storage in between, and then we can actually tell App Mobility in one single command to move the application, or clone the application rather, from the source to the destination cluster. So basically, the entire application gets captured in a bunch of gzip files, and then we create a snapshot or maybe a group snapshot of all of the PVs that are included into this app and move them into S3 as well. In the next stage, we use App Mobility to actually restore that CSI storage and then restore the application. So we end up in using just a single command with a new instance of the persistent Kubernetes application in the destination cluster. So next, let's run a demo. What could possibly go wrong? Hi, and welcome to our new demo video. Today, we will be moving a stateful application from an on-prem data center into the cloud using Dell CSM App Mobility. So let's look at the environments first. This is the on-prem environment, and if you look at it, it is a small K3s cluster that is running some workloads, and it is backed by a Unity storage array. So if I say get me the storage classes, you can see that there's two storage classes currently created for the Unity, one for iSCSI and one for NFS. So here I also have a small application running. So if I say get me the pods, you can see that in the default namespace I have a WordPress application running. So 2 pods, and with that come, in this case, 2 PVCs. So you can see I've got a MySQL PVC that is 20 gigs in size, and I've got a WordPress PVC that's 5 gig in size. So if I look at the Unity array, you can actually see here on the block that yes, indeed, these volumes are running here. You can see by the name, it's coming from K3s, 20 gig and 5 gig in size. So basically I want to take this application and move it into public cloud. So that brings me to the second environment that we've got standing by, and that is a small Kubernetes cluster. So this is an RKE2 cluster that's running on AWS. This one is actually also backed by a storage array, but it's backed by a Dell PowerFlex storage array that is also running within AWS. So if I go here and I say kubectl get me the PVC, get me the storage class, you can see that yes, there's a PowerFlex storage class here. I also have a small workload running in the default namespace. You can see, so this is just a test pod. And then, yes, it also has a bound PVC pointing to PowerFlex. So if we're looking in the PowerFlex environment, you can see that, yes, there's also been some volumes defined. You can see there's 3 volumes at the moment. One of those is the one that we just viewed, and there's some other ones as well. So we'll be looking to move not only the application, but also the persistent volumes from the Unity onto this system in one swift go. So both sides actually have application mobility already installed. And if you look at the configuration here, you can see that I had to obtain a license, and that basically is a license file that you can create a secret with. And after that secret has been created, you can actually use Helm to install application mobility. If you look at the value file that I built, you can see that it's actually pointing out to US East 2, so it's pointing into Amazon S3. So we also have an Amazon S3 bucket configured here. And if I browse to that bucket, you can see that there's some stuff in here, right? There's no backups at the moment, but it's already initialized some of the things that it needs to actually function properly. So on the source side, so out here, I have prepared a file to actually create a backup. So creating the backup is pretty straightforward, right? Using this YAML file, I have to give the backup a name, obviously. I have to specify the namespace where application mobility is running. And I also have to specify this namespace, so the default namespace. So anything running within the default namespace will be grabbed and backed up by the system. So with that, I can basically start creating the backup. So I simply apply the backup.yaml. There we go. And now I can use the tool called Dell CTL to actually look at the backup. So I need to specify the namespace again. And you can see that the WordPress backup is, at the moment, it's in progress. So when we now look at the S3 browser and I refresh, you can see that there's now a folder created called backups, and you can actually see the backup here. So this is all being filled at the moment. So right now, application mobility is using Restic and Valero to actually grab all the bits and pieces of the WordPress application and basically zip them all up and get them to run here. So on the other side, we of course can do a restore. So if you look here, I prepared a file that's called restore WordPress. You can actually see that here we again need to specify the namespace that we're running application mobility on this side. So that's the same namespace in this case. We got to give it a name. So we're going to call it restore WordPress. And the backup name, of course, that's where it's coming from. Then we have a namespace mapping from default to WordPress, which means I know that the original was running in the default namespace, but I would really like to restore in a new namespace here called WordPress. So at the moment, that is not created yet, right? So there's no WordPress at the moment. There's one more thing to consider, because if here you look at the storage class, it's of course a different storage class from the source, right? The source was the Unity VSA, destination is PowerFlex. So in order to make that work, there's one more thing that you need to do, right? You need to create a config map. So right here, I created a config map in the namespace application mobility. that actually does a Unity VSA01 minus iSCSI, so that's the source storage class, and map it to the destination storage class of PowerFlex. So now if we do a restore, the system will understand that what used to be running in the storage class for Unity now needs to go into PowerFlex storage class. So let's see how far we got with the backup. Yep, the backup has been completed. So now we are ready to perform the restore on this end. In order to do that, I simply execute kubectl apply and then basically run the restore YAML file that we created. So the backup has been created, and basically what we should be seeing now is that if you do a get namespace, you can see that now we have a WordPress namespace created. If I look into this, so get all for the namespace WordPress, you can see that, yep, lots of stuff is running. You can actually see that the 2 pods are already running. If I look at the PVC, you can also see that there's now these 2 PVCs are running here. They're both bound. As PowerFlex always has increments of 8 gig for volumes, you can see that the 5 and the 20 gig volume are now 8 and 24 gigs. We can actually verify this. So when we look at the volumes, you can already see that there's more volumes created. So the extra volumes that were actually mapped from a Unity directly put into this PowerFlex, and now we have a running environment on the destination side. So this concludes the video for today. I hope you enjoyed it and hope to see you soon. Bye bye.